Okay, so this is section 6.1 and is multivariable linear systems. Multivariable linear systems and row operations. Okay, so problem number 1, we're supposed to do numbers 1 through 5. So let me help you with number 1. Problem number 1 reads 5x equals to 3y minus 31 and is 2y equals to negative 4x minus 22. So first of all, we need to set it up as a system of equations, first the x's and then the y's and then the solutions. So when I do that, I'm going to have to move the 3y to the left, the x to the left. So that would be first the x, 5x, and then the y minus 3y, because when you turn it to the left, it becomes negative, equals negative 30y. Then the second equation should be 4x, and then plus 2y equals negative 22. Now, this is just a system of equations, x and then y's. Now, the thing here is that we need to, first of all, we can do it different ways. Okay, with my 7th period, we try to switch it around, put the 4x first, so we flip it, and the 5x as the second row. That's one way of doing it. And then we multiply the first row times 1/4 to make it a 1. And then that 1, we multiply it by the negative 5 to get rid of the 5. So that's one way of doing it. The other way that you can do it is by having the x's to have the same denominator, the same number, the same coefficient. Did you remember from Algebra 2 how to make the 5 and the 4 into the same number? But in this case, one has to be positive, the other one has to be negative. How can we do that?
Like you make them the least common multiple.
Or even faster, you just multiply.
You multiply by the opposite.
You multiply by the opposite, yes. So the first one, you multiply by negative 4. The second one, you multiply it by positive 5, right? Minus 3y, and then it's a 4x plus 2. Okay, let me erase this, and then I'll be right there with you. Okay, I cannot erase that thing. Okay, this is supposed to be just positive 5. Not negative, but positive 5. Okay, what was the question, Brenda? When you move the 3y to the left, since it's positive, it becomes negative.
Yeah, but right here it shows that it's a negative.
The problem on the textbook, it says that it's negative? Okay, so then if that is from the problem, negative, then when you change it, it would be positive. So thank you, because then that's going to mess up everything. So that becomes positive then. Great, awesome. Okay, so now we multiply the first one by negative 4 and the second one by 5, so that we can have the same. So we're going to go ahead and target this kind of like the eliminations method. Okay, so we multiply by negative 4, that would be negative 20. And then by negative 4 is negative 12y. And then by negative 4, that would be 4 times 1 is 4. 4 times 3 is 124. And then negative 5 times the second equation would be negative 20x. Negative 5 times 2y, negative 10y. Negative 5 times negative 22 is positive 10 carry 1, so it's 111. And that would be negative, right? Because it's positive 5 times negative 22, that becomes negative. So now that you have, okay, what happened to the 20? I'm sorry, but I'm thinking that this is negative and it's not negative, right? That's a positive, so that's a positive. So it's positive, the second one is positive, and then the answer is negative. Okay, so we have everything okay now, right? And then from here, we can go ahead and cancel out now the x's. combine the y's. So that would be negative 2y equals positive 14. And then we just divide by negative 2. And y equals negative 7. Then once you know that y is equal to negative 7, we go back and plug it into one of the original equations. So one of the original equations, let me copy it. It could be 5x plus 3y equals negative 31. The one where we move the y over to the left side, which is the first one, this one. Then you substitute the y for negative 7. So that would be 5x plus 3 times negative 7 equals negative 31. So it's 5x minus 21 equals negative 31. We add 21. So 5x equals negative 10. And then when you divide by 5, okay, let me just write it over here on the side. That would be x equals negative 2. And so the solution, we put the solution, and the solution would be, you put first the x, which is negative 2, and then the y, which is negative 7. And that is the solution. So it's kind of like, you know, the same thing that you did in Algebra 2, right? The elimination method. Okay, so any questions on that problem? So far, so good. Okay, so now let's move on. It was 1 through 5. So number 1 is a whole number, it's whole numbers. Number 2 is whole numbers. Number 3, one of them is going to be a decimal. Number 4 is going to be decimals. And number 5 is whole numbers. Okay, so let me do number 6, so that way you kind of know what to do with number 5, because number 5 is the one that is with 3 equations, kind of like the example I gave you in class yesterday. I'm trying to find the section of the homework. We found it. Okay, right here. So you have number 5 from homework. Let me work in number 6. Another page.